All right, for my class, this is really where the organic chemistry part started to happen. So, from my textbook, this is chapter 4 material, and you start learning about alkanes, which they don't have no functional group attached to them. Really, kind of hydrocarbons, you have your carbon and hydrogens to them. We started to learn about isomers and substituents and whatnot. So, what Alex is asking us to do in this question is determine whether the following structure are the same compound, constitutional isomers are neither. And what it's going to do is it's going to show us two different compounds or structures. So, kind of my tips for this one as you go into this chapter material is learn what your substituents are. Like, so below here, I have the common ones that were used in my class. So, of course, you got your methyl, your ethyl, your purple, isopurple, your sec butyl right here, and your terp butyl right here. So again, take some time to read your textbook or maybe some other YouTube videos and really learn your substituents. Next for this one, let's define the terms. Isomers, pretty much the same element, so it's going to have the same amount of carbons and hydrogens, except they're just going to be bonded differently. So say you might have a um, isobutyl or isopurple or somewhere in a different location, or you just might have a different way that the carbons are attached to each other. But in that case, that'd be a isomer. Now with the same compound, it's exactly what it's in the saying. It's the same compound, and then neither pretty much means it's going to have like a different number of carbons or hydrogens. And then kind of my tips is count your main carbon chain and identify your substituents, and then count carbons and hydrogens. And then at the end, if you wanted to just make sure you can like draw it out and rotate it to kind of get a picture. So let's start with this first one. So we'll start by counting the carbons on the main chain. So I count 1, 2, 3, 4, 5, 6. All right. And then I go to my other compound right here and I'll count, say in this case, I'll go 1, 2, 3, 4, 5, 6. So what I notice is I have 6 carbons on my main chain. So now I want to focus on these substituents that's hanging out here. So on carbon 2 right here, I have a methyl. And on carbon 2 right here, I have a methyl. So I can note on both those carbons, carbon 2, I have a methyl. For carbons 3 and 5, and again right here for carbon 3 and 5, I notice I have a ethyl. So I could just write right here, 3 and 5, I have a ethyl. So with that being said, I can just quickly look at this and I can say, because I have those groups and everything's accounted for, substituents, carbons, hydrogens, I'll pretty much say this is the same compound. But then if I want a clarification or kind of still learn this early on, you can just draw it on, maybe host something up to the screen. I'm gonna copy this real quick, kind of copy, paste this on, and I can rotate it. In this instance, I'll rotate it down or rotate it to kind of that point. And as you see, kind of not the best at rotating on here, but as you see, it's kind of the exact same compound. So that's like a pro trick you can use at the end just to verify your information. So we'll label this the same compound. All right, going up to this one, I'm gonna count them from my main carbon chain. I got 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 right there for that chain. 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 on this chain. So I notice this is a difference. So next I'll focus on my substituents and what I see with this one, I have a isopurple right here on carbon 1, 2, 3, 4, and the same right here on carbon 4. But then I notice at this end, I have kind of at this last carbon or, the last carbon or whatnot, that I have kind of two methyls you could say hanging off. So my next focus is just going to be on counting overall carbons in the compound. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 carbons on this first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case, I can count, I got 12 carbons. But again, I noticed that the substituents are not the same for them. And then at the end, I just want to count to make sure that I have my hydrogen. So I got 2, 4, 6, 8. So I got 8 right there, along with 3, 6, 9, 12. That's 20. So say in this case, I got 3, 6, 9, 12. So 15 plus 8 plus 1, 2. So in this case, I'll say I got my 25 hydrogens, right? So as you kind of count and go through, you'll develop your own system for how you go about it. But 3, 6, 9, 12, 15, along with these two that are on these CH2s right here, that's 8. And then I got 1, 2, 3. So that's 25 hydrogens. And then I come over here, look at my other structure, count them out, see that I still have 12 carbons, and I count through it and I got 25 hydrogens on this structure as well. So that's going to be a clear indicator for this one that this is going to be a constitutional isomer. So again, same number of carbons and hydrogens, but different substituents or kind of attachments to how it's built. And then the last one, I'm kind of going to count the carbons in my main kind of cyclo chain, which you're going to learn about later. But 1, 2, 3, 4, 5, 6. And I noticed that with this other chain that it's the same, that I got 6. So next I'm going to count my substituents. So I got a ethyl right here. But then on this carbon, you kind of see how they're similar. You have, let's count it, 1, 2, 3, 4. So you have a, or should say 1, 2, 3, 4. So you have kind of a sec butyl right here. And then right here, you got more of like a pentane. So let's count the carbons here. You got 1, 2, 3, 4, 5, versus with this carbon chain, you only have 4. So because of that, that means your carbon count don't match up. So in this compound right here, you got 5 carbons right here, 6, 7, 8, 9, 10, 11, 12, 13. 13 carbons. With the structure over here to the left, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So because you have that difference in carbons, it's mean that they are different compounds, different structures completely. So in this case, we're going to write neither. So again, this takes some practice. You can develop your systems to learn what worked best. But again, you start with really, counting that main carbon chain, identifying your substituents, and then at the end, you're counting your carbons and hydrogens to make sure, if they match up, and then just how they're structured at the end. And then if you have a difference, it's going to be neither. So if this video helped you or your classmates, feel free to like, share, and subscribe to the channel. But like I said before, this is where the real kind of organic chemistry is going to start now.